Yeah, it's a similar problem. 2013, number 4. So we'll do another one similar to that one that we were just doing. 2013, number 4. Alright. So it says, the figure above shows the graph of f prime, the derivative of a twice differentiable function f on the closed interval 0 to 8. The graph of f prime has horizontal tangent lines at 1, 3, and 5. So basically they're just telling you that the slope at these points, 1, 3, and 5, is 0. The areas of the regions between the graph of f prime and the x-axis are labeled in the figure. The function f is defined for all real numbers and satisfies f of 8 equals 4. So keep that in mind. Alright. So find all the values of x on the open interval 0 to 8 for which the function f has a local minimum. That's another way of saying a relative minimum. And you have a relative minimum anytime the derivative is 0 or undefined, and it changes from negative to positive. If you think about what creates a minimum in a graph, a low point in a graph. It's a point where your slope is either 0 or undefined, and then if I think about minimum, okay, what a minimum looks like, low point on a graph, it's where the slope has changed from negative to positive, right? It's changed from decreasing to increasing. Alright, so when you look at this graph, remember that this is the graph of the derivative. So we're not talking about the minimums on this graph. We're talking about where does the function f, that this is the derivative of, have local minimums. So we're not looking at the graph that we are being asked about. We're being asked about f, but we're looking at the derivative of f. So we need to look at this graph and find where is this graph equal to 0, or where is it defined. It's not positive. There's only one spot that happens at, and that would be right here at 1, 2, 3, 4, 5, at 6.
Why would 5 not be it?
Because this is the graph of the derivative, and we're looking for where the derivative is 0. So that would be here, here, and here. Right? If this said the graph of f, then 5 would be the answer. Right? Because we're looking for where f has the minimum. This is not f. This is f prime. F prime has the minimum at 5. So it's not asking me where f prime has the minimum. It's asking me where f does.
But how do you know the point 1, 5, or 1, 4, and 6?
Because those are the places where the y value is 0. Those are the places that has a 0, right?
Okay.
1, right, because it crosses the x-axis there. Stretches across the x-axis. The only one where it also changes from negative to positive is at 6, where it goes from below to above. These are always confusing. These are really hard for me to get when I first started teaching this, because you're not used to thinking that way. But just remember that they're asking you about f. Where does f have a local minimum? But they're not providing you the graph of f. So minimums on this graph are not minimums of f. So you have to remember that to find a local minimum, anywhere that the derivative, which this is the derivative, is 0. So there's 3 places where it's 0. And it changes from negative to positive. So the only place where it does that is at 6. At 4, it changes from positive to negative. So at 4, there would be a local maximum. And at 1, it does change sign, so there wouldn't be anything at 1. Right. Because it doesn't change signs here. It doesn't go from above to below or below to above. It's above on both sides. It's positive on both sides. Right. So at x equals 6. And this would be our justification. Where the derivative is 0 and it changes from negative to positive.
So minimum is negative to positive.
And maximum is positive to negative, yeah. And if you get confused, I always just draw myself a picture. minimum, maximum goes negative slope to positive slope. Maximum goes positive slope to negative slope. Alright, so let's see, this is the 2013. Yeah. Yeah. If you're looking at the graph of the derivative, either way it has to be 0. And then it also has to have the right sign change. Alright, so 2013, number 4. Let's see here. Okay. Only 1 point, that one. Yeah. So x equals 6 is the only critical point at which the derivative changes from negative to positive. So, yeah. So, yeah, but our justification is fine. It doesn't have to be exactly. Like, critical point is just a point where the derivative is 0 or undefined, which we said that. We said that's where the derivative is 0. Yeah, I don't think you have any of the points. Yeah. 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 Alright, so then on part B, determine the absolute minimum value of f on the closed interval 0 to 8 and justify your answer. Okay, so relative is just anywhere that you're basically that your graph changes direction. Absolute means like the absolute highest point on the graph and the absolute lowest point on the graph. So like this is not the one we're looking at, but if we were to pretend like we wanted to know the absolutes on this one, the absolute maximum would be here and the absolute minimum would be here. But this is also a relative maximum. These are both relative minimums. Does that make sense? But the absolute highest point on this graph is here. The absolute lowest point is here. No, because we're not talking about f prime. We're talking about f. Okay, so they told us that f of 8 was 4, right? Alright, so if you look, each of these areas adds or subtracts value from your function. Because if this is the derivative and we wanted to know the function, we would integrate. When we integrate, we count areas. So this is saying that the total value of our function by the time we get here to 8 was 4. Alright, so I'm going to kind of work backwards because they started me with the very end of my graph. They started me with 8. Alright, so at 8 the value was 4. So if I work backwards, alright, from here to the next place where you have a change in the area. So from 8 back to 6, I'm going to subtract this area of 7, right? Because the total up to 8 was 4. They would have added 7 when they went from 6 to 8. So we're going backwards, so we're going to subtract 7. Oh, sorry. You totally can't see that, can you? Right, sorry. So all the way here, the value is 4. We're going to work our way backwards to figure out where in here did it have its absolute minimum. Then if I go back to 4, right, from 4 to 6 they would have subtracted this area, so when I go backwards I'm going to add it. And then back to 1, where they added, so I'm going to subtract it. And then here they would have added 2, but I'm going to subtract it. Basically, if I start here at 0 with a value of negative 8, then I would add 2 to get to 1, right? Because you add the area if it's positive. Then from 1 to 4, I would add 6. Then from 4 to 6, I would subtract 3. 6 should ever. Yeah, because I'm going backwards. Because what they gave me was where it ends instead of where it started. Does that make sense? That was kind of tricky. When we figure out B, and row. That's the lowest y value. And I think justify your answers just to show that. So let's see. Let's see what they say. Liquid soup. Let's see. Alright, so they wanted to make sure that you considered 0 and 6. We considered more than that, so we would be okay, because we also considered 1, 4, and 8, which you technically didn't have to. I'll show you why in just a second, but to me it was easier just to do the whole thing. But at least 0 and 6, you had to consider those two. And then your answer, the absolute value is, or the absolute minimum is -8. And your justification is just where we showed our work, where we showed what each of the values were. Alright, so you don't have to write all this out. They just want to be able to see that you found f of 0 and you found f of 6. And you found, and you used the f of 8, right, equals 4. And then you just pick the one that was the smallest. So that's 3 points. Alright. Okay, so here's a part that's actually like one on the last one we did. So let's see if I can get this one. So on what open intervals contained in 0 to 8 is the graph of f both concave down and increasing? So it should have positive y values and negative. Yes. Well, your alternate can't compete. Like,
okay, I'm sorry. So if Chris steps in,
yep,
he gets in the top 3.
Yep.
And Carson competes as.
I know, that would be a good question. I will find out. Like, basically, Chris made it on his own.
He made it on his own. Like, he gets in the
But
top
then you want to sub for him on a team event?
Yes.
Yeah, I don't know. I'll have to see.
Okay. Because it's possible.
Okay. Alright, so positive y value, negative slope. So that would be from 0 to 1, from 3 to 4, and that's it, right? 0 to 1 and 3 to 4. That's where your second derivative, which is the slope of your first derivative, right? So that's where your slope is negative, but your y value is a positive. Mm-hmm. You can write it out in words.
Okay. If you still have to define like what part was supposed to be negative.
Right.
Like you say negative slope and positive y value, do they count that, or do you say negative slope for the second derivative?
Yeah, that's probably what they would want to know. Alright, so let's see. So this is worth 2 points. An answer, 1 point for the 2 intervals, you'd get a point, and then 1 point for, but that is where the derivative is positive and decreasing, which means a negative second derivative. That's fine, either way. Alright. This part was like we did before. Okay, and then part D. I think this is similar as well. Function g is defined by g of x is f of x cubed. If f of 3 is negative 5 halves, find the slope of the line tangent to the graph of g at 3. So basically find the derivative of g and plug in 3. Right. So what rule do I have to use to find the derivative of g? The chain rule, right? 3, the cube is the outside, f of x, the function f of x is the inside. So we do the derivative of the outside, the cube, which means we bring the 3 down to get a 2. Leave the inside alone, times the derivative of the inside. Alright. So now I'm going to plug in 3. So I'm going to do 3 times f of 3 squared. So that's why they told you this up here. F of 3 is negative 5 halves. So negative 5 halves squared times, and then f prime of 3, since this is the graph